Hello everyone and welcome back to our course. Here I am in Google Colab and we are going to begin our project of building a video recommender system. Alright, here I am at colab.research.google.com and you can visit this website to follow along in Google Colab. We're going to begin by creating our dataset. Alright, so for that we're going to import the NumPy library. This is a very common library used in data science, data analysis, machine learning, because it provides tools for scientific computing and also it provides the NumPy array type, which acts as a wrapper for the Python list. And it allows you to access a whole range of complex functions perfect for data science and machine learning. So I'm going to use NumPy to create an array of zeros with the function zeros. Then I can pass in the shape. I'm going to pass in 100 by 5. Note that the shape is a pair here. And we are going to have 100 rows and 5 columns. That's this shape. And as well, we're going to pass in the data type, which is going to be Boolean. So we're going to have just ones and zeros, 1 for true and 0 for false. We're going to store this as our x variable. Okay, so this will be a variable x representing our inputs. We're going to have 100 inputs with 5 features each. Each input is going to represent a viewer, and each column represents a channel of videos that the user may or may not have watched. All right, so then let's make all of the columns. So I'm going to call this features, and this represents each of the 5 features per input. And in our case, the features are going to be the video channels that the user may have watched and that they may watch in the future. All right, so we're going to have 5 channels. I'm just going to make up some channels here. Investing 101, funny cat videos, as well as Bureau Tech and Mammoth Interactive and video game reviewer. Okay, so these are 5 different channels, and we're going to build a system that is going to take a data set and determine which videos to recommend the user or the viewer. So first we need the data set of history. So we could find a data set on the web, we could scrape data, we could also just create our own sample dummy data. I'm going to choose the latter option. We're going to create some sample dummy data ourselves because it's going to be easier for us to understand the project if we understand the data set from the ground up. All right, so let's create this data set. It's going to contain true if the viewer has seen the video and liked it. And it's going to contain false if the viewer did not see the video. All right, and so for that, I'm going to go for index in a range of x.shape 0. So I'm going to go through the first index, so the rows, and I'm going to create a row representing a viewer. And we're going to have a Boolean for every single feature. The Boolean will be true if the viewer liked that video, and it will be false if the viewer did not like that video. So then we're going to have this data set of history, and we're going to see if they liked one video but they didn't like another video, and that means that they're more likely to watch videos that they liked. So we're going to find correlations among the different channels. For example, if we find consistently that viewers liked investing but they hated cats, then we know that we shouldn't recommend cat videos to people who like investing. Similarly, if we find that a viewer liked Bureau and they liked video game reviewer consistently, if we find that consistent among our viewers, then we know that we should recommend video game reviewer to watchers of Bureau because there is the correlation. So we're going to build the data set of sample history, and then we can use that data set in the future. So when we get a brand new viewer, if they liked investing, we would not recommend them cat videos, and if they liked Bureau we would recommend them video game reviewer because we have the history of correlation. Now we don't actually know the correlation right now. We're going to have to create a data set, and then we're going to have to find the correlation among all the different channels. And note that liking a video doesn't mean you have to hit like. It just could mean anything. It could mean that you watched it till the end. It could mean that you didn't skip that much of it. All of that could be liking a video. All right, so let's create all of our features. I'm going to start by checking if numpy.random.random is less than 0.3. So I'm just selecting a random number with numpy.random. And this means that we can just set x at our index at the column 0 to equal 1. So I'm just going to say that 30% of the time, I am going to set Investing 101 to true, meaning that the viewer liked the channel Investing 101. They liked a video by that channel. NumPy.random returns a value between 0 and 1. So by checking if it's less than 0.3, it means that 30% of the time, I'm going to create Investing 101 and give it the value of 1 at that index. So this x at index, that represents the row, but then this 0 represents the first column of that row. So we're going to go through all of our rows because x.shape at 0 is 100. We're going to go through all 100 rows, and 30% of the time we'll populate the first column with a 1. The other 70% of the time, we will just have a 0 there because we created this numpy.zeros. But 30% of the time, we will say that that viewer liked Investing 101, and it will be random. This is just us generating a random data set to work with. All right, then I'm going to add a nested if statement here. I'm going to check if numpy.random.random is less than 0.5. So I'm going to say 50% of the time. I'm going to say that x at index at column 1 is equal to 1. So 50% of the time of 30% of the time, so really much less than 50% of the time, I'm going to take that same row, but add column 1. So that means that the second column, because remember, indexing begins at 0. So this 0 represents funny cat videos. This 1 represents, or no, this 0 represents Investing 101. This 1 represents funny cat videos. We're going to set it to 1. So that means that first we're going to 30% of the time say that the viewer liked Investing 101. And then 50% of the time of that 30%, we're going to say that the viewer also liked funny cat videos. So we're going to have a small portion of viewers who liked both Investing 101 and funny cat videos. All right, great. So we're going to have 30% of viewers who liked Investing 101, and then 50% of them will also like funny cat videos. So we can already see some small amount of correlation that we're creating, because some viewers will like Investing 101 and funny cat videos. But we have to keep going, and we have to create potential correlations between all of the different channels. And just to make this more clear, I'm going to give this a constant name. So let me just call this my Investing 101, and I will say index, and that is equal to 0. All right, and then I'm going to say the second channel is funny cat videos. Index is going to equal 1. So just that you're clear about what that 0 and that 1 means. And this index here, or the for loop for index in range x.shape 0, that represents one of our rows. So one of our viewers. So I can say for viewer in a range of all of my viewers. So I can actually make this a constant too. I can say viewers count is equal to x.shape at 0. So typically you want to have constants where possible to avoid what's known as magic numbers, so to make it easiest for your viewer to understand, or anyone looking at your code to understand what is going on. All right, so this 1, remember, that represents that the viewer did watch the video. So I can say watched, or liked even. It represents that they liked the video. So I'll say liked video equals 1. Let me just replace that as well. All right, great. So that makes it a little more clear what is going on here in the code. Next up, let's keep going, and let's add another nested if statement. Let's say if numpy.random.random is less than 0.2. All right, then I am going to say x at the current viewer at our next column, which is going to be column index 2. We'll set that to equal 1. This column 2, that represents our next channel, which is Buratech. So I'm going to make that index Buratech index constant, and I will set that to equal 2 because it's the next feature. Then I'm going to replace the 2 with Burotech index, and I'm going to replace the 1 with liked video. All right, let's keep going. Let's check if numpy.random.random, let's say, is less than a different value like 0.3. All right, then I'm going to set x at viewer at my next index, which is index 3. I'm going to set it to equal liked video. Now, what is index 3? Well, index 3 is the next channel, Mammoth Interactive. So let's make that Mammoth Interactive index, and we'll set it to equal 3, because that's the index of that channel inside of our features array. All right, and then I can replace 3 with Mammoth Interactive index. All right, and we have one more channel we have to handle. We have to handle video game reviewer. So let's add another if statement here. We'll say if numpy.random.random is less than any other value we want, like for example 0.4. Then we'll set x at viewer at our last index 4 to equal liked video. Note that these checks less than 0.5, less than 0.2, those are all random. Okay, I just randomly chose those because I'm just creating a random sample data set for us to work with. But you could replace this with any values you wanted. Just make sure they're between 0 and 1. Okay, so what is index 4? Well, that represents the video game reviewer index. So I'm going to make video game reviewer index equals 4. Then I can copy that and replace the 4 with that. All right, next, let's make the else statement. So let's say that the viewer did not like the investing video. Then we'll use an else statement. And in this case, I can just do the same thing again. I can, again, make an if statement and check if numpy.random.random is less than 0.5. Then I'm going to set x at the viewer at our funny cat videos index to equal liked video, which is just 1, meaning true. And all right, then we can again create a nested if statement inside of that. We can check if numpy.random.random is less than 0.3. So this time we're actually going deeper into the nest, take note. This time we're checking if the user did not like investing and they did like funny cat videos, then we'll give a small percentage chance of a correlation with another channel. So we're going to take x at viewer at our next index. So let's see, after funny cat videos, we had the Burotech index. So let's take Burotech index and let's set it equal to liked video, if in this case of this very small chance. Then I'm going to make another if statement for our next channel. So if numpy.random.random, let's say, is less than 0.2, then I'm going to set x at viewer at our next channel index, which is Mammoth Interactive index. So I'm going to put in that next index and set it equal to liked video. So I'm creating these small chances of correlation. And as you can see, trying to understand the correlations ourselves would be a lot of work. So we're going to use data analysis and math, as well as algorithms, to find the correlations between channels for us and to determine what videos should we recommend users or viewers. All right, we have one more channel to account for. So I'm going to say if numpy.random.random is less than, let's say, 0.4, then I'm going to just paste this line again. And just make sure you have the indentation exactly lined up, because in Python indentation matters. And we're going to set the video game reviewer column to liked. Then we can actually make another else statement for that nested if statement. So that means if the viewer did not like funny cat videos, and there's a 50% chance of that. And note that we're still inside of the greater if statement, that, or the greater else statement, that they don't like investing as well. So we're going deeper into the nest. Then we'll use if numpy.random.random is less than 0.7, and we are going to move on to our next channel, which is Burotech. So note that we're not starting at funny cat videos this time, because We've already accounted for that with this if statement. This if statement has already set funny cat videos to true 50% of the time. So we can't include that channel again in this else statement. Then I'm going to add another if statement. I'm going to check if numpy.random.random, let's say, is less than 0.55. Then I am going to set our next channel, which is Mammoth Interactive. I'm going to set it to liked video, so 55% of the time. And we have one more channel to handle. So if numpy.random.random, let's say, is less than 0.8, then we're going to set the video game reviewer column to liked. All right, and that is going to be enough of the data set for us. Now, of course, we could keep going deeper and deeper, create more correlation if we wanted to. All right, and we can account for the case that, let's say, if, I'm going to just check here, one more case, and that is going to be 2 tabs in here. If x at the index.sum is equal to 0. So this is a case we have to be careful of. What if our viewer didn't like any videos of that channel? Because it is possible. It's possible that the viewer, never found that channel, never liked it. Oh, actually, this should be just 1 tab, by the way, not 2. So let me just make sure it's just 1 tab. So we're still inside of our viewers, right? But what if after all of these checks, our viewer just happened to not like any of the videos? Perhaps they never even saw them. It's another possibility. Then we have to recommend them something. So that's what this if statement here is for. If x at the current index, or I have at the current viewer, I should say, if the sum is 0 for this current viewer, that means they have 0 for Burrowtech, they have 0 for Mammoth Interactive, they have 0 for Video Game Reviewer, they have 0 for every channel. So we have to recommend them something though, because we only have these, let's see, how many channels do we have? These 5 channel options. So we have to recommend them something in that case. So I'm going to take, in that case, x at the current viewer, and at the last column, let's say Video Game Reviewer, we'll set it equal to 1 or liked video. So this means that if they didn't like anything previously, we'll just recommend them the last channel, Video Game Reviewer. All right, and of course, if we had a real video website, then we could recommend them a completely different channel, because we won't have only 5 channels. But for the purposes of our project, we only have 5 channels in the whole site. And just like that, we've created our data set. So you can see we've used random instances to set whether or not a viewer liked a video. Now let's actually save all of this data to a file, and we'll see what we got. All right, so for that, I'm going to use numpy.saveText. So this is a function that allows me to save my NumPy array to a text file. It's quite a useful function. I'm going to call this viewer profiles. So let me just call this that .txt. So I'm creating a text file. I have to pass in that as the name of the text file that's going to be created. And then I am going to pass in x, which is my array, my NumPy array that I want to actually convert into a text file. And I can set the format as well, %d. All right, and just like that, we'll already actually have viewerprofiles.txt. So we could print out viewerprofiles.txt, just make sure it's in a string. All right, so we can already grab it by its reference. I'm just going to run this code cell now, and that's going to create our data set for us and then convert it to a text file. And look at that, we can, okay, never mind, actually you don't want to refer to it as a string. What am I thinking? That will just print out the string. Okay, so viewer profiles, we have this, and we have viewer profiles.txt. We can actually refer to that later on. So all we have to do is use numpy.loadText, this load text function, and we can refer to viewer profiles.txt. That has to be a string because you're passing it into the load text function. So look at this. We can already see what we have. We have numpy.loadText. So we are just showing what we have in this text file. Now, as well, I can just download this text file to my computer. So for that, I'm going to use from google.colab. I'm going to import the files module. Then I'm going to call files.download, and I pass in the string, which is the name of the text file that I want to download. And that's actually going to prompt me to download the file to my computer. So look at this, downloading, and then you'll have a pop-up up here. Okay, there is our pop-up, and I can hit save. That is going to save that txt file actually to my computer. That's not a necessary step because, as I showed you, you can just actually now use it here in your Google Colab immediately by its name. Because when you call save text, it's going to save it to this Google Colab instance. But then if you want to actually download it for your reference, you have to download it with files.download. Now if I click on that txt file, I can pop it open, and let me just toggle full screen so I can bring that up. Here it is. So this is the txt file that's been generated. Okay, look at this. We have 100 rows and we have 5 columns per row. And at every column, we have a value 0 or 1. 0 represents that the viewer liked the video, 1, or did not like the video, I should say. Yes, and then 1 represents that the viewer did like the video. All right, and we can see all of those rows. Okay, everything's looking good, so that means we successfully created our data set. And now we can just start to use it inside of Google Colab. For example, as I already showed you, we can just call numpy.loadText, and we can load that viewer profiles.txt file. And we can save it as X. It's not really necessary, but it's good to have as a reference. And just like that, we're just going to take our text file and load it into a NumPy array. So we're just doing the reverse of what we did where we downloaded it. Now we're just putting it back into a NumPy array. And you need to know this because sometimes, and usually, you won't be creating your own data set. You'll actually be getting data sets. And they often come in a TXT format or a CSV format or a JSON format. So you do need to know how you can load it back into X. Then we can verify that we do have the file. So what we have to do is we can call x.shape, and we can print out here the shape of X to make sure we got all 100 rows and 5 columns. Okay, great. And look at that, 100 by 5. So 100 is the number of samples and 5 is the number of features. All right, awesome. So just like that, we have been able to grab our data set that we created. And we can also get more values from it. For example, we could just get the first 5 rows like this. And just like that, we're returning only the first 5 rows in the data set. Note this dot here is because we allow decimals. Okay, and there are many more operations you could perform with NumPy because this is a NumPy array. So it's not just a regular Python list. It's actually a NumPy array type wrapping around the Python list, which means you can perform much more nuanced operations. And we need that very often in data science and machine learning. NumPy is used in almost all projects because it allows you to make more mathematical operations with your lists. The Python list regular type is very good, but it is limited in comparison to the NumPy array type. Awesome. Okay, next up, now that we have built our data set, we are going to continue the project and we're going to learn how we can determine if a person watches one channel, like if a person watches Investing 101, how likely is it that they will also like funny cat videos? So we'll find correlations between different channels. If they liked Burrotech, what is the support that they would also like Mammoth Interactive? We will continue that project in the next lecture.